So today we are doing graphing rational functions. So we'll do quite a lot of things today. So this is what we are going to do. I just want you to grab your pen and your book. So today we are doing this is what we are doing today. We're doing graphing. We're doing the graphing of rational functions. Graphing rational functions. Then under graphing rational functions, we shall look at what we call the slant, asymptotes. Then we shall also look at vertical asymptotes. We shall look at horizontal asymptotes. etc. So now these are going to be very important for us in today's lesson. They will be able to help us to graph whatever we are going to be looking at. So I'm going to start with this question. First of all, before any question, I would want to put a very important concept. The first concept I'm going to put is this. Whenever you have the graph y is equal to 1 over x, whenever you have the graph y is equal to 1 over x, the way your graph, guys, is going to come out like, I want to give you how the sketching of your graph is going to come out. The way your graph is going to come out for this particular graph, you are going to have a graph which is going to start from that particular point. Then it will be moving in this direction. Then because it's moving like that, you're going to have also the mirror image, which is going to flow like that. Okay, that's the mirror image that you're going to have for this particular graph. Now, if for example your vertical asymptote is 0 and your horizontal asymptote is 0. Vertical asymptote implies x is equal to 0. Horizontal asymptote implies y is equal to 0. How do you find the domain and the range for this? The domain implies all values in the x. So in the x-axis, you have this guy here, and this is negative infinity. Then positive axis, you have this guy here, which is positive infinity. Then you have this guy here, which is your vertical asymptote. So when you're finding the domain, you're coming from negative infinity to some point 0. The union of the same 0 but to positive infinity. Okay, that's one thing that you must know. Then for the range, is this value. You're going in the y, so this is positive in the y. And then this is negative in the y. And then 0 is your exclusion. So you're going to have from negative infinity to 0, the union of 0, comma, positive infinity, like that. This is one thing that you must understand. Then, how about if, for example, you're having this graph. I just want to focus about these two. How about if you're having this graph, y is equal to 1 over x to the power 2. How is the graph going to come out like? Whenever you have something like x to the power 2, whenever you have something like x to the power 2, or you have y is equal to 1 over x to the power 2, it implies that the way your graph is going to come out like, it's going to be like this. Please, I want you to pay attention so that when you see me graph, you'll be able to grasp the concept. It will come out like this, in this direction, okay? Then you also have something like this, in this direction, okay? So if your graph is in this axis, it's going like that. Make sure that you also have another axis, another mirror image, which is going to come out like that, okay? Then you realize that the highest value will depend with the vertical asymptote, horizontal asymptote again. So make sure that you know how to mirror these graphs. Okay, so this one I've plotted here is for this guy. This one I have plotted here is for this guy. So the two are going to open our minds, because I don't think they can even give you up to the 3rd degree. Okay, they usually give you to the 2nd degree and the stuff and the like. Another concept which I want you to understand just now is this. It's going to be C. Now, under C, how do you know that there is going to be a slant asymptote somewhere? How do you know a slant asymptote exists? If you have been given a polynomial, then there's denominator, then there's numerator. If you have been given a polynomial function, then the numerator has got a very, very, very big degree, or has got some high degree, let's say 2, compared to the numerator, compared to the denominator, then this has got a slant asymptote. If you've got this to the 3rd degree over x to the power 2, the slant asymptote is there. But whenever they are equal, no slant asymptote. And whenever you have the numerator smaller than the denominator, there is no slant asymptote. Only when the numerator has got a higher degree compared to the denominator, that's when you are going to have this particular kind of a beautiful graph. I want you to thumb me up to just notify me that you have understood what I have taught there. Thumbs up, thumbs up, thumbs up. Thumbs up. Is it clear? Now, let's go to the thing. We are going to start with the first question. The first question is simply saying that graph the following rational functions graph the following rational functions, find the domain and range, then also find the vertical asymptote, horizontal asymptote, and slant, asymptote if any. Now I'm going to start with the first question, which is given f of x is equal to 1 over x minus 1. How do you graph this one? How do you do everything? It's going to be simple. I'm going to show you the concept. The first thing that I'm going to do, guys, I'm going to find my vertical asymptote. Vertical asymptote is found when x is equal to 0. So I can get what is in the denominator. I think I taught x minus 1 is equal to 0. Therefore, x is equal to 1. That becomes my vertical asymptote. My horizontal asymptote is going to become 0. Why? Because what is on top and what is down there, we do not have an x. I think we know by now what I mean. It's a 0. Okay. We have found the 0. What else can we do from here? What else are we able to do? Let's try to sketch the graph. So I'm going to sketch the graph. Now, how do I sketch this graph? To sketch this graph, the first thing I'm going to do, I'm going to first of all sketch my vertical asymptote. So this is going to be 0, 1, 2, 3, 4, 5. Neg 1, neg 2, neg 3, neg 4, 1, 2, 3, 4. Neg 1, neg 2, neg 3. I'm going to sketch my horizontal asymptote. So I'm going to bring in my ruler. So let me sketch my vertical asymptote. Is here. So my vertical asymptote is here. Okay, I've plotted my vertical asymptote. Then I need to plot my horizontal asymptote. Okay, my horizontal asymptote is 0, so the same thing again. I'll do the same thing even here. So my horizontal asymptote is here. This is where my horizontal asymptote is in the 0 image there. What else can I do from here? I'll need to plot now. You will need to come up with some coordinates. Remember, it's a sketch. So what you do is this. You already have the function of f of x, right? Get a number, get your vertical asymptote. Your vertical asymptote is 1. Please get this secret I'm teaching you now. Your vertical asymptote is 1. Yes. Your horizontal asymptote is what? 0. Then get one number which is on top of 1. So I'll say 2. Get one number that is below 1. So I'll say the number below 1 is 0. Even here, vertical asymptote. Get one number that is above 0. It's 1. Get one number that is below 0. Negative 1. Then plot. So I'm going to say x, y. Then get the figures that you have. So you can start with this number here that you have there. You can say 0. Then you get your 2 there. So you can get your 1. You can get your 2. Then you get your negative 1. Please get what I'm teaching here. Then you ask yourself 0. If you put 0 into this equation, what is it going to be? If you put 0 here, your y is going to come out as negative 1. So you say negative 1. If you get f of x, you say 1 over. If you put 1 here, where there is x, if you put 1 where there is x, this thing won't be able to hold. So that point won't be significant. If you get 2, you put it here. It will be 1 over 2 minus 1. It will give you 1 over 1. So this will give you 1. If you get 1 there, then you put negative 1 there. For the last point, you say minus 1. You're going to get 1 over negative 2, which will give you negative 0.5. So let's try to plot the first one. The first one is 0, negative 1. 0, negative 1, it's at this point. 0, negative 1 is at this point. Okay. 0, negative 1 is at that point. 2, 1, 2, 1 is at this point. So, have you seen? Then negative 1, 0.5. Negative 1, 0.5 is at this point. Now notice what is happening here. You have this point here. You have this point here. So already that one tells you what your mirror image is going to be like. So it will be coming from here. Then it will be passing here. Going in this direction. Even this side, your mirror image will be passing from there. Going downward. Like that. Have you seen how easy this thing is? Then your domain is coming from, this is negative infinity, this is positive infinity. So it will be from negative infinity. Then what is your vertical asymptote? Where x is equal to 1. So this will be comma 1, union, then 1 to positive infinity. Then you get your range. It's coming from negative infinity, which is here, all the way to positive infinity. So your horizontal asymptote where y is equal to 0. So you're going to have 0 there, union, 0 all the way to positive infinity. That's how you find the first one. Thumbs up, thumbs up, thumbs up, thumbs up, thumbs up. If you have understood on the first one, I came to simplify this, and I'm off. I'm going to be using the same concept.
On the coordinates for x, the -1.
Get,
Where did you do that one?
I said, get your vertical asymptote. Your vertical asymptote is 1. Get your horizontal asymptote. Get one number above 1. Get one number below 1. Horizontal asymptote. You come to horizontal asymptote. Get one number above 0. Get one number below 0. Combine the coordinates. So when you combine the coordinates, you have this 0 here, which is here. You have this one here. All these are x values. You have these 2 here. It is here. You have this -1 here. It is there. Then you place in this. Then you get your y values. Hello?
Thank you, I understood now.
Okay, let's do the second one. We see if it's gonna be easy for us. B. You have f of x is equal to 1 over x plus 4, then plus 1, right? That's what you have. Now, how do you solve this one? So, for such type of questions, guys, unless otherwise they've asked you, but you don't even need to find the intercepts, unless otherwise you've been asked to find them, but no need. Okay? Unless otherwise you've been asked to find them. But the way you go about it, you find the vertical asymptote first. What's your vertical asymptote? Your vertical asymptote, you get this part. Vertical asymptote is found when x is equal to 0. So you say x plus 4 is equal to 0. Then your x eventually becomes -4. Horizontal asymptote, we know that this part here for the horizontal asymptote, this part here is equivalent to a 0. Because we know that, okay, I think by now we know how to solve them. This is a 0 there. Because we have x down there, we only have 1 there on top, a constant. So it's 0. So because it is a 0, we say 0 plus 1, and we get a 1 there. So we can therefore say that our y, or our horizontal asymptote, is going to be 1. So the 1 is going to be shifting the graph. The graph is going to be shifting by 1 upward. Now, how can we graph this? I'm going to use the same concept. I'm going to use the same concept. Okay. Now, I have plotted the graph. I'm going to get my vertical asymptote. Vertical asymptote, I have it is -4. Then I'm going to get my horizontal asymptote. It is 1. I'm going to get a number which is above -4. What number is that which is above -4? -3. Again, a number which is below -4. What number is that? -5. Then I'm going to get a number above 1, 0. I'm going to get a number below 1, 2. Sorry, a number below 1 is 0. A number above 1 is 5. So it's 2. Then I'm going to sketch. So I can say x, y. Now, I can get all the values. So I have a 0 there. I have a 2 there. I have a -3. I have a -5. Then I can ask myself, I have y is equal to 1 over x plus 4 plus 1. So y is equal to, if I put 0 here, I'm going to have a 4 there. 4 plus 1. 4 into this, it's 4. Multiplied by 1 is 1 plus 1 into 4, it's 4 multiplied by this is 4. So I'm going to have something like a 5 over 4, which is just 5 into 4. It's 1 point. Remainder 1. Then this is a 0. 4 into 5. Sorry, 4 into 10. It's going there two times. Remainder 2. So you put a 0 again. 4 into 20 is going there 5 times. So whenever you put you put x there, you're getting 1.25. Okay, 1.25. How about if I put 2? So if I put 2 here, I say 1 over 2 plus 4. Then I'm going to get something like 1 over 6 plus 1. So this is 6. This is going to be 6 into that is 1. 1 multiplied by 1 is 1. Plus 1 into 6. 6 multiplied by 1 is 6. So this would be like 7 over 6. 6 into 7 is 1 point. Remainder 1. Then 6 into 10 is going there 1. Remainder 4. So by the way, it's just, okay, let's just put it at 1.1. So you can also say, if you put 2 there, you'll be getting a value of 1.1 somewhere there. Then you get to the -3s, to the negative figures. You get 1 there. Then you say, if you put -3, you say -3 plus 4. Today, okay, -3 plus 4. You're going to get 1 over 1 there, which is 1 plus 1 is going to give a 2. So if you put -3, you are going to get a 2 there. Okay, how about if you put -5? If you put -5 there, -5 plus 4 plus 1, you're going to get -1 here plus 1. So this is going to be -1 plus 1, which is going to give us a 0. So you're going to have a 0 here. Then you can look at your x. With x the biggest, the smallest is -5. So you can say this is going to be -1, -2, -3, -4, -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Then you sketch. What is z? 0, 1.5. So 0 is here, 1.5. 0, 1.5 is somewhere here. So wait, let's sketch our vertical asymptote first. Vertical asymptote is here. These are vertical asymptote. Our vertical asymptote is a -4. So let's plot it. It's here. This is our vertical asymptote is. How about our horizontal asymptote? Our horizontal asymptote is at 1. So let's also sketch it. Like that. Okay. Then we ask ourselves, now we sketch our points. So 0, 1.25 is somewhere here. So if you see a point there, you leave it. Then 2, 1. So you say 2, 1.1. 2, 1.1 is somewhere here. So already that gives you the image where your graph is going to be for that one. Yes. Then -3. -3 is here, 2. -3, 2 is somewhere here. Then -5. -5, 0 is somewhere here. So for this one, the point that you're going to follow, looking at your what's this? Your vertical asymptote, looking at your vertical asymptote, looking at your vertical asymptote and your horizontal, you're going to consider this guy here. Okay? You're going to consider this guy there. Now, when you consider that guy there, which other point are you going to consider? The point which is making sense for you. So, this is going to guide you. It implies that the other one, the way it's going to come out in this direction. Your domain is going to come from -infinity to -4, union of -4 to +infinity. Your range is going to come from -infinity all the way to 1, union of 1, all the way to +infinity. So you have found that one. Thumbs up if it's clear.
So I have a question.
Okay.
Yeah, why do you have those 2 points and plotted?
Because when under this topic, one thing that you must understand is you are looking at the behavior of the function. You're looking at the behavior of the function, and also you're looking at how the graph is going to behave when you get points that are close points that are close, number one, to your vertical asymptote and your horizontal asymptote. Are you getting what I'm saying?
Yes, sir.
You're looking at the behavior. So, if you have some kubati, there are some, as you get close to the vertical asymptote, as you get close to the vertical asymptote, as you get close to the vertical asymptote, the way the points are going to behave, they might be shifting from your vertical, from the line that you have drawn. Okay, have you seen? There are some other points like this one, it was stationed here. This one is stationed here. But this one is in the right position. This one is also in the right position. So, you make sure that you target the points that are in the right position. It will even be able to tell you, say, but this is the right position. This is how it should come out. Okay? Moreover, the graph is even able to tell you because this is a graph of 1 over x. Okay? Like I mentioned at first.
All right.
Yes. Okay? I'm sure you have heard your lecturers may say, let's determine the behavior of the curve as we get points close to the this, as we get points close to the that. So that's how we manage questions under this. If I goes on, I don't think there's anyone who would plot a graph at this point here. Clear? Okay. Let me proceed. I go to the next question. The next question okay, let me just get some bundles. Let me check the amount of bundles I have. Whatever I remained with. Okay, quite low. Let me just buy bundles. Guys, are you getting the concept that I'm teaching? I'm only using one concept here. Okay, let's come to, okay, much more. We have now enough bundles. Let's solve this one now. It's an interesting one. See, f of x is equal to, we have x minus 2 over 3x. How do we plot this one? How do we plot this one? So, for such type of equation, it's very simple also. So we're going to say, what is our vertical asymptote? So our vertical asymptote, we know that it is going to be 3x is equal to 0 over 3 over 3, and our x is equal to 0. Then what is going to be our horizontal asymptote? Who can tell us what our horizontal asymptote is in this particular question? Someone to just unmute themselves and just tell me.
It's 0.
Horizontal asymptote is 0. Are you sure?
Yeah, it's positive 2, it's not 0.
Huh?
If it's not 0, then it's positive 2.
No guessing. No guessing. What is our vertical asymptote? Remember, you're having something like, this is just the same ones. Y is equal to x over 3x. So in this case, what is our horizontal asymptote?
Yes.
Huh?
Yes.
It's 1 over 3. So horizontal asymptote in this case is 1 over 3. Okay, that's our horizontal asymptote, 1 over 3. So we have the horizontal asymptote of 1 over 3. Then we do the same things now. Let's see if I'm able to do even much more. Okay. So for such type of a question, I'm going to be solving everything that is needed for the sake of practice. So let's try to find the x-intercept for the sake of just mathematics. So x-intercept is found when y is equal to y is equal to 0. So we put 0 there, x minus 2 over 3x, cross multiply. You are going to have x minus 2 is equal to 0, then x is equal to 2. That's x-intercept. How about y-intercept? So the y-intercept won't exist because the y-intercept is found when y-intercept won't exist. Why? Because y-intercept is found when x is equal to 0. And if you put your 0 here, it will be undefined. So this doesn't exist. Y-intercept doesn't exist. We only have the x-intercept. So for this one, let's try to do the same thing. Vertical asymptote. The vertical asymptote is at what? 0. Okay. So this is 0. That is our vertical asymptote. Horizontal asymptote, where is it? It is at 0 point something. 1 divided by 3, it is 0.3. So this is why it is somewhere here. So that is going to be our horizontal asymptote. Then we get our vertical asymptote. Which is 0.3. So, okay, for this one, let's just get a figure which is very close. Okay, sorry, vertical asymptote is 0. Vertical asymptote is 0. Horizontal asymptote is 0.3. So we can say 1, 2, 3, 4, 5, 6, -1, -2. Just put in Charlie Mama numbers to guide you. -4, -5, -6. This will be -1, negative 2, negative 3, negative 4. This is 1, 2, 3, 4, 5. Right? Now, we can use the vertical asymptote. We can get a point that is above 1, a point that is above 0, and a point below 0. The point that is below 0 is negative 1. Let's see what happens. So we are going to have 1, negative 1. This can help us a lot. Why do I say so? Because you know that these are mirrors. They are mirror images of each other. So if you put 1 here, 1 minus 2, then you put 1 where there is x there, you're going to get, this is going to be 1 minus 2, it's going to be negative 1 over 3. So you're going to get negative 1 over 3. Then how about if you put negative 1 here? So it will be negative 1 minus 2 over negative over 3, then negative 1. So this is going to be negative 3 over negative 3, and it will give you negative 1. So this will be negative 1. Then you ask yourself, what is 1? 1 comma negative 1.3. Negative 1.3 somewhere here. Have you seen? So already I have a point, a nice point. It's told me where my point is. So my point for the first one is here. Okay? That's the first point that I'm having. So I don't even need to go further to plot. I don't need to go further to plot. Okay? The first point is even able to give me something. Okay? So already I know that my graph is going to come out like this. Okay? Even when you get points for this one, the number which is above 0.3, maybe you say 0.1. Okay, maybe you can say 0.1 and the 0.4. Okay, so you can say now that one I'll use a calculator. Now the problem, okay, let's just use a calculator. It's okay, 0.1 minus 2, and then divide by 3, then is 0.1 inside. Anyway, so when you have a mirror image of that type, you know what, guys, don't even waste time. It's a sketch. They are asking you to sketch, not to plot. It's a sketch. So already you know where your mirror image is going to be like, where it's going to be, where it's going to hold from. Okay, so that's how you are able to tell. One should be able to tell you where your everything is going to go to. And by the way, this is going to be a positive. This is a positive 1. Positive 1. So negative 1, comma positive 1 is somewhere here. You've seen? Guys, have you seen? Have you seen? Hello? Monica, Have you seen how the graph is beautifully coming out? Just one point.
Yes, sir.
Just one point. Just one beautiful point. And I'm able to know where my graph is going to be. So your domain, this is going to be your domain, negative infinity to positive infinity. So you said domain is going to come up from negative infinity to which point? Zero. Union, 0 to positive infinity. Range, negative infinity to 1 over 3. 1 over 3 to positive infinity. Okay. We do another one.
Sir, a question, please.
Mm-hmm.
I didn't understand how we got how to find the horizontal asymptote, the 1 over 3 there, how we got it.
Did you go through the first lesson where I was teaching asymptotes?
How?
Hmm?
No.
So now you didn't go through me, what should I do? You want me to start teaching you asymptotes now? You are new?
Yes.
When did you join?
This week.
When?
Forgotten the date.
You need to go through the lesson on asymptotes. It's there already.
Alright.
Okay. You reconnect. You connect so that you see how I'm solving the vertical asymptotes, horizontal asymptotes. Okay, I taught first horizontal, vertical. I taught horizontal asymptotes, vertical asymptotes first, so that at least it becomes easy for you to. It becomes a walkover. Okay, so which other one now are we going to do? Okay, let me do E. This one is f of x is equal to x minus 1. Then this one is going to be x to the power 2 minus x minus 1. Okay, we have this interesting question. How do you plot a graph of this? So, the first thing you do, you find your vertical and horizontal asymptotes. The same thing. So, your vertical asymptote is found when x is equal to 0. So you get what is in the denominator. You equate it to 0. Then from there, you say product, or you can say your sum, then product. What is your sum? Your sum is -1. Your product is 1 multiplied by -6, which is -6. What are your factors? Two numbers, if you add them, they give you -1. If you multiply them, they give you that. So it's going to be -3 and 2. So you're going to say x to the power 2 plus 2x minus 3x minus 6 is equal to 0. Then x plus 2. Then here you say you factor 3, -3. Then xc plus 2 equal to 0. So you're going to have x plus 2 there x minus 3. So your vertical asymptote is going to be x is equal to -2 and x is equal to -2. So x is equal to 3. Your horizontal asymptote, because this guy has got a very big denominator, okay, very big degree compared to the one on top, horizontal asymptote is 0. Can we find the y-intercept, x-intercept here? We can try. What is going to be our x-intercept? X-intercept is found when y is equal to 0. So we can put 0 here. Then we say x minus 1 over x to the power 2 minus x minus 6. When you cross multiply, you're going to get x minus 1. Then you're going to get x is equal to 1. Then let's check for the y-intercept. Y-intercept is when x is equal to 0. So if you put your 0 here, your 0 here, your 0 here, we are going to get a y-intercept of 1 over 6. So we have gotten our y-intercept, x-intercept, we have gotten our asymptotes, vertical asymptote, horizontal asymptote. This graph here does not have a slant asymptote because the numerator has got a small degree compared to the denominator. Now we can plot. Let's try to plot this graph. Okay, this becomes a 0. This becomes a 1, becomes a 2, becomes a 3, becomes a 4, a 5, a 6, a 7, a 1, a 2, this is -3, -4, -5. 1, 2, 3, 4, 5. -1, -2, -3, -4. So I'm going to draw my y-intercept, sorry, my vertical asymptotes. They are at -2, so I'm going to draw. The other one is here at x is equal to 3. I've drawn. Vertical asymptote, where is it? It's at 0. So this becomes our vertical asymptote. Where is my x? My x-intercept? Sorry. Where is my x-intercept? X-intercept is at this point. It's at x is equal to 1. X is equal to 1 is here. That's why my x-intercept. Y-intercept is at y is equal to, this is 1 over 6, which is 0 point something. So let's just put it here. Okay, then we can get our vertical asymptote. Vertical asymptote, we found we can deal with this one first, this one here. So for this one, where x is equal to 3, let's get the number which is above 3 is going to be a 4. A number which is going to be below 3 is going to be a 2. So it can tell us anything that we want. So let's try to check what is going to happen. Guys, we are going to put a 4. So I'm going to say x, y. The same thing. I'm going to get a 4, put it there. I'm going to get a 2, put it there. Then I'll say 4. If I put a 4, what there is x, so it will be 4 minus 1 over, this will be 4 to the power 2 is 16, minus 4 minus 6. So 4 minus this is going to be 3 over 16. This will be negative 4 minus 6, which is negative 10. Then 16 minus 10 is going to give me 6. That and that will cancel. It will give me 1 over 2. So I'm going to get 1 over 2 here. If I put a 2 here, 2 minus 1 over 2 there, it's going to give me 4 minus 2 minus 6. So this will give me 1 over. This part is giving me negative 8. 4 minus 8 is negative 4. So this will give me minus 1 over 4. Let me plot the first one. The first one is a point and it's going to be here. So 4, 0.2. 0.2 is here. So already, guys, I'm able to get something that is beautiful there. Okay, I'm able to get something beautiful there. So I can plot it. When I'm close to these 3, I'm getting a graph which is coming out like this in that direction. Let me just plot for every, let me just consider all the values. Okay, so these were for 3. Let's get also for negative 2. When vertical asymptote is negative 2, when x is also negative 2, so you can get a number on which is above negative 2. A number above negative 2 is negative 1, then negative 3. So if we are getting negative 1 and negative 3, what are we going to be getting, guys? Let's say negative 1 there, comma 1 over negative 1 to the power 2, the negative 1 there, minus 6. This will give me negative 2 over, this will give me 1 plus 1 minus 6. So this will give me 2 minus 6. It will give me negative 4. So this will give me something like 1 over 2. So here I'm getting half again. How about if I put negative 3? Have you seen what I've done, guys? I've gotten close points. Negative 2 for this line and Q3 for this line. This side Q3, I found that point. I want to try out Q2. I see what point I'm going to get. Negative 3 minus 1 over, then I say negative 3 here to the power 2 minus negative 3 minus 6. I'm going to get negative 4 here over, this will be 9, positive 9 plus 3 minus 6. So 9 plus 3, it's 12. 12 minus 6, it's 12 minus 6 is 6. So here I'm getting, this is 2, this is 3. I'm getting 2 over 3. Okay, so I'm getting negative 2 over 3. Negative 2 over 3, same as it, negative 0.6. Negative 0.6. I have all the points. Let me plot them. Let me plot 2, comma 2, comma negative 1 over 4, which is 0 point something. So 2, comma 0 point something, 2, comma negative 0 point something. I'm getting this point here. 2, comma 0 point something. It's this point. So 0 point something in the negative axis. Yes. Then negative 1, comma half. Negative 1, comma half is this one. It's this point here. Have you seen I've got another beautiful point? And then I'm getting this part again, which is negative 3, comma 0.6. It is somewhere here. What does this tell me? This tells me that, first of all, I'm going to sketch. I'm going to have a graph in this axis. Remember what I said, guys. I said when you have something like this, the graph was coming out like this. You saw? Like this. And that's what's happening. Yala was a graph. Depending with where your points are, or it can be in this direction and this direction. Okay? So for this one, check what is happening. My graph is coming out like this. At the same time, I have a point also. I have another point with this point here. But you can't draw in front of the vertical asymptote. So already this tells you your graph is going to come out like this. In the same line where your point is. Don't pass it where the point is. Just in the same line. Even this side, it will come out like that. Have you seen? Then you had these 2 points there. You had a point here, a point there, a point there, a point there. So your graph for this one, it will come out like this. Okay, simple. What is your domain and your range? It's the same thing. So you're going to have domain is going to come from where? It will be coming from negative infinity to negative 2, union of 3 to positive infinity. Range, the range will be coming from where? Negative infinity to 0, then 0 to positive infinity. That's how you graph these things. If you check, I'm using the same concept. Same concept, same concept, same concept. Practice makes everything perfect. Guys, any question? Thumbs up if it's clear. Yeah, you can ask a question. Messi, you have a question?
No, I don't have a question.
Okay. Yes, what are you saying? Okay, so there's no question, right? There's no question? I proceed. Let me do the one the question I was given yesterday. There's a question I was given yesterday. It's a question from the mathematics paper. The math paper for 2024. Where is it? Okay, let me search for it. Let me search for it. I think I have it here. Someone posted, Asa, help us with this one also. So let me help you. I show you how to solve this question using the same concept that I'm using right now. I'll be very slow on this one. Where is it? Okay. So this was the question. The question was f of x the question was saying determine the intercept C, the vertical, the horizontal, and slant are asymptotes if any for this particular question. So the question is, let me just put it as f. So you have g of x is equal to x to the power 2 plus 1 over x to the power 2 plus x minus 2. So what you do for this one, guys, very simple. Find your vertical asymptote first. Vertical asymptote is found when x is equal to 0. So I'm going to get my x power 2 plus x minus 2 is equal to 0. Get the product, the sum. What is the product? The product is simply negative 2. The sum is simply 1. Then you discover that two numbers, if you add them, they give you this. It will be negative 1 and 2. Yes, negative 1 and 2. If you sum them, they will give you 1. If you multiply them, they will give you negative 2. So this is going to be x to the power 2 minus x plus 2x minus 2 equal to 0. Then x minus 1. Then 2, then x minus 1 equal to 0 there. Then you're going to have x plus 2, x minus 1. Your vertical asymptotes are going to be x is equal to 1 and x is equal to negative 2. These are vertical asymptotes. Horizontal asymptote, guys, who can tell me? The horizontal asymptote, because you have the same degrees, your horizontal asymptote is going to be 1. Guys, already in your head you have a picture of how this graph is going to come out like. It's a graph of this. Forget about what is on top. As long as you have x to the power 2, you already have an idea how your graph is going to come out. It's either it will come out this way, or if it's coming out in this direction, under this line, then it's going to have a mirror image of that way. Please make sure that you have an idea of how the graph is going to come out already before you sketch. Say sketch, remember. Super simple. Simple, actually, this is the simplest to sketch. So when you reach there, what else can you do? You can find your y-intercept. So y-intercept is found when, x-intercept is found when y is equal to 0. So if I put my y, I put my 0 there. I'll discover that I'm going to have a x to the power 2 plus 1 equal to 0. Then I'm going to have x to the power 2 equal to negative 1, square root of that, square root of negative 1. And my x is undefined. This tells me the x-intercept doesn't exist. How about y-intercept? So for the y-intercept, you find it when x is equal to 0. So if you put 0 there, you're going to have a 1 there on top. 0 here, you're going to have negative 2. And your y-intercept becomes negative 1 over 2. So y-intercept is negative 1 over 2. We can plot this graph. First of all, let's find the coordinates. Get your vertical asymptote. So I'm going to get vertical asymptote. The first vertical asymptote is x is equal to what? 1. The second one is when x is equal to negative 2. Get a number that is above 1. Zero. Number below 1, 2. Okay, sorry. Can confuse people for the sake of learning. Number above 1, 2. Number below 1, 0. Number above 2. Number below 2. Sketch. Make points. Coordinates. Get all the points. You can have a 2. You can have a 0, which is here. Then you also get your 2. You also get your negative 1. You also get your negative 3. Let's start putting in the points. If I get 0, I put 0 here. 0 there, I'm going to get negative 2. Meaning, if I put 0 there, it will be negative 2. It will be negative 1 over 2. Yes, if I put 2 there, it will be 4 plus 1. If I put a 2 there, here, to be a 4. A 2 there to be 2 minus 2. So this is going to give me 5. This will give me 0 over 4. 4 into 5, it's 1. Remainder 1. 4 into this is 2. Remainder 2. 4 into 20 is 5. So if I put 2 there, it will be 1.25. How about negative 1? This is washala washala. I see that you understand the concept or you don't. This is simple, simplest concept. -1 there. Then -1 here. -1 here. This is going to be -1 to the power 2 is 1 plus 1 over. This is 1 minus 1 minus 2. So this is 2 pamwamba. Then this is going to be 1 minus 3. This will be 2 -2. This will be -1. So here I'm getting a -1. How about if I input -3? I'm teaching you how to get the coordinates the simple way without even going any far. -3 here, -3 here, -3. This will give us a 9 plus a 1. This will give us a 9 minus a 3 minus a 2. So this will give me 10 over 4. So 10 over 9 minus 5. So 10 over 4, which is just the same as 2.5. Now let's try to plot. So let's try to put our points here. If you have 0, then you have -1 over 2. If you have a 2, then you have 1.25. If you have -1 here, you have -1 here. If you have -3 here, you have 2.5. Let's try to plot, guys. Let's try to plot. I can put 0 here. 1, 2, 3, 4, 5, 6. At least you can take it per 6 so that you don't become stranded with your points. One, 2, 3, 4, 5. 1, -2, -3, -4. So let's now plot the vertical asymptote first. Vertical asymptote, we have it where? At x is equal to 1. At x is equal to 1, we have a vertical asymptote. Same concept, guys. Same. Yes, and also at x is equal to -2, you have a vertical asymptote there. And then you have a horizontal asymptote at x at y is equal to 1. And then what else? We can plot what we have. Meanwhile, you already know how your graph is going to come out like, because this is x to the power 2. So let's plot this point first. This point, notice how interesting this thing is. This point here was already our y-intercept. So by using the concept I'm using, where you get the numbers on top of the vertical asymptote, 1 point on the vertical asymptote, one point below the vertical asymptote, it will even give you the intercepts. You've seen this y-intercept. It's already here. This is the first point that we have here. It's here, these coordinates. Okay. 0, comma, negative 1.2. It's here. I'll plot that one. I'll put it there. I'll leave it there. Then 2, comma, I'm going to go per 2, comma, 1.25. 1.25 is here. Have you seen? I already see. So this one, this point that I've plotted, it can tell me, it's enough for me to even know how the graph is going to be like. Because already I know the other graph is going to, I already know the graph is going to come out like that point that I've plotted there. Okay? Guys, it's very simple, very interesting. The next point is here. It's negative 1, comma, negative 1. Negative 1, comma, negative 1 is this point. Just put it there. Then negative 3, comma, 2.5. You see? Negative 3, comma, 2.5 is here. Guys, it even tells me how my whole thing is going to come out. So now, I'm going to have a graph which is going to come out like this. Yes, and a graph that is going to come out like this. This is your tutorial. This is your test, previous session test question, the one you sent in the group. Now, how about this part? This part is telling me how the graph is going to come out like. So this one, it will be going downward. How is the domain and the range going to be like? Then, so the domain is going to be like this. Negative infinity to what? To negative infinity to negative 2. Then 1 to positive infinity. The range, it's coming from negative infinity to 1 to positive infinity. Well. Notice how the graph is. The graph is starting from this point. So it's coming from 1. It's coming from 1 all the way to positive infinity. This is your range. It's coming from this point, going upward. That's how you solve this question, guys. Now, of course, thumbs up if it's clear. Thumbs up, thumbs up, thumbs up. Okay. Maybe perhaps I can do a last question. Two last questions. Just two. One for the slant asymptote. The next one, I'm going to be very fast. It's the function of negative 2 over x power 2 minus 5x. Guys, we do the same thing, eh? get your vertical asymptote. So it's this to the power x to the power 2 minus 5x equal to 0. Then x minus 5 equal to 0. So x is going to be 0 and x is also going to equal to 5. Those are vertical asymptotes already. Horizontal asymptote is 0. That we already know. Y-intercept. The y-intercept is found when x-intercept found when x is equal to 0 and it doesn't exist. So x-intercept doesn't exist. Does not exist. Y-intercept is found when x is equal to 0. So y-intercept, where is it? Y-intercept does not exist as well. Because if you put 0 here, you put 0 there, 0 will be in the denominator. Doesn't exist. So get your vertical asymptote. Even this side. Here you are getting a point, number above 0, number below 0, number above 5, number below 5. Make coordinates. Get 1, put it there. Get negative 1, put it there. Get 6, put it there. Get 4, put it there. Should start with 1. So you can put your 1 there. So this is going to be negative 2. This is going to be 1 minus 5. This will be negative 2 over negative 4. And it will give us half. So already here you're getting 1 over 2. How about if you put in negative 1? If you are going to put in negative 1, to be negative 2 here, to be 1 there, to be 5 here, it will be 6 here. So it's going to be negative 1 over 3, which is just the same as negative which is just the same as negative 0.3. So I'm getting negative 0.3 here. If I put in 6, I'm going to get 36 here. And then a 5 multiplied by 6, 30. So negative 2, there I'm going to get a 6. And then I'm going to get a negative 1 over 3, negative 0.3. If I put a 4 there, I'm going to get 16 here. I'm going to get a 20 here. I'm going to get a 4 there. I'm going to get a 1 over 2 here. So this will be 1 over 2, which is 0.5. Even here, which is just the same as 0.5. I can plot these points. Can someone unmute themselves and just tell me, have I changed the concept ever since I started solving this? Hello? Have I ever changed any concept? So let me plot. 0 here. Vertical asymptote. Okay, let me just 1, 2, 3, 4, 5, 6, the biggest number. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4. Vertical asymptotes. What did we get? We got 0. So let me plot my vertical asymptotes first. 1 is at 0. The other one is at 5. I'm going to plot the first point. 1, 0.5. 1, 0.5 is here. Leave the point there. The second one is negative 1, negative 0. So negative 1, negative 0.3. So negative 1, negative 0.3 is here. Have you seen, guys? Guys, don't be jealous. Have you seen what the point is? Have you seen how I have already? I'm able to see how my graph is going to come out there by the point that I've shaded, the second point. Then 6, 6, negative 0.3 is here. Another beautiful point here. Another beautiful point, I've gotten it, it's here. That's the good part about this concept. Then I can plot 4, 0.5 is still here. Now, how will my graph be? Guys, simple. This one is even beautiful. It's very beautiful, this one. I'll show you. It's here. Even this one is coming out this way. To prove to you that x to the power 2 comes out this way. Now, how about the 2 points? Exactly. Exactly what you are thinking, bro. Connect the 2 points. Okay, so this one, now, do you know the thing? The thing is, I need one more point so that I determine where my graph is going to go to. So let me do this. Here, I have a 6 on top. Here, I have a 4. So I can say, let me put a 3 down here. A 3. I can also get just a 3. If I get a 3 there, why am I putting 3? Because shiva my points are area. Shiva area punch area pamulo, so I want to determine that. So you get another number below 5. So I got 4 and 3. So if I put 3 there, three. No, let me get 0. So 0 had 1 on top, negative 1 down here, negative 2. So let me get negative 2. Okay, good. Oku nasenda ko shinga. Oku ninsenda ko 4 na 3. Let me first try 3 up. So I'll have a negative 2 over, you'll have a 9, 15. So negative 2, what is 9 minus 15? negative 6. So this will be 1 over 3, which is negative 0.3. So which is positive 0.3. So if I put a 3 there, it will be 0.3. Let's see if it's going to help us. 3, comma 0.3. Three comma 0.3 is here. Somewhere punch up. And already I know where my graph is going to. Have you seen 3 comma 0.3 kariapaka point? So meaning this graph is going like this. Then you can do the same thing. You find your domain and your range. Guys, any question? Not sure, Pef.
The horizontal asymptote. You didn't include the horizontal.
Huh?
I'm saying you didn't include the horizontal asymptote.
Horizontal asymptote, I didn't include it. It's here.
Yeah, I mean protein.
It's here. It's 0. Any question? Anything hard here? Okay. So if you are good enough, you can practice, try out yourself. Now, how about if you have a question which is like this? Y is equal to x to the power 2 minus 3x minus 7 over x plus 3. Guys, this one has got a slant asymptote because the numerator's got a degree which is greater than the denominator. Whenever you have something like this, just know that you have a slant asymptote. So of course, we can find our vertical asymptote. X plus 3 is going to equal 0. X will equal negative 3. That's our vertical asymptote. Okay. Horizontal asymptote doesn't exist. Let's find our slant asymptote. To find your slant asymptote, do synthetic division. Synthetic division. So you have negative 3 there. Twarifundaka the synthetic division. Then you can get the coefficients. You have 1 there, negative 3, negative 7. Just drop your 1 there directly. Negative 3 multiplied by 1 is negative 3. Negative 3 plus negative 3 is negative 6. Negative 3 multiplied by negative 6 is positive 18. Then negative 7 plus positive 18 gives you 11. So your equation is going to be x minus 6. And then this is going to be your remainder. Then you get this part. This part is called the slant asymptote. So your slant asymptote is x minus 6. So you can plot, you can make a graph like that. If your x is 0, you're going to have negative 6. If your x is 1, you're going to have negative 5. Let's try to plot, we see what we're going to get. Vertical asymptote is at negative 3. Then you can plot these points. Okay, let's plot 0, negative 6, 0, negative 6, 0, negative 6 is this point. And this point is going to be enough. And then 1, 5. Okay, there will be enough. 1, 5. Eh. One comma 5 is somewhere here. Now this graph is not going to yalachepa graph yakaenei. Figures. Okay, let's say if I use if x is 4. If x is 4, then this will become negative 2. Catch a graph. So let me try to use big figures. If x is 5, this becomes negative 1. So 4, 2. 4, negative 2 is here. 5, negative 1. This is too far. What numbers can I use? Okay, let me try to use the negatives. My screen is very small, so if I plot the line, it won't come out the way. Unless if I was using a big page. So I'm trying to get figures that are going to be. Okay, how about if I say, if I use negative 1, if x is negative 1, if x is negative 1, y is going to be negative 7. If x is negative 2, y is equal to negative 8. So negative 1, negative 7, somewhere here. Then in negative 2, negative 8 is somewhere here. So, of course, I know the graph is, this thing is going to move like this. You draw your straight line. but the way it was supposed to be nga twakapuishaka namune fyalava te nga twakapuishaka parapa pa point po fyala safukumanefi just that naichepa. Have you seen, guys? Just that naichepa nani kaniandi. Have you seen what I'm talking about? There's a point where the two are going to meet. Like, there's a point where this line here. Okay, let me put it as an illustration. Let's say the points were close, right? The same way we have these 2 points. Let's just imagine paper that's very cool. Then maybe the 2 points are somewhere here. When you plot, the line comes out like this. This is your slant asymptote of this is your xc minus 6. Then kwaraba pa point po fyala safukumani napa. So this vertical asymptote and the slant. Then kuprotera mukati umuso. You're going to have your graph coming out from this side. At the same time, your graph is going to come out from this side as well. No. Vaishe nanaka. But that's how it's going to come out. Okay? That's how it should come out. If you plot. Any question? So uku, the same way where the two are meeting hapa, so you plot your graph like this. Then this side you follow the same line, and the line which is cutting hapa pa our XY plane. Don't extend up to this side, no. That's how you do your things. That's how you sketch.
I have a question. The y is equals to x minus 6. Where's it coming from?
Synthetic division, mama. Did you do?
Oh, okay. I remember.
Okay. Guys, that's how you solve these questions. Please go through today. Else muzaibala.